This is Wadko Karim, and welcome to our second part of the video. This is chemistry and grade 10 work. So this is about chemical bonding. So for those that followed me in the first part of the video, we looked at some of the differences and we defined the kind of bonding. So in this case, we are going to look at now the actual examples in bonding. Okay. Okay, so now remember that ionic bonding involves the transfer. Okay, so the transferring. Okay, so there is a transferring of electrons from the metal. Okay, from the metal to non-metal. So you have to understand that this is going to be about the transferring of electrons from metal to non-metal. So, for example, you are going to have sodium and chlorine. Okay. So before you do any kind of diagram representing this bonding, you have to know that sodium is presented as Na and with 23 and then 11, and then for chlorine we have 35.5 and then 17 as a number of proton. So these numbers are the ones that are involved in the combination of sodium and chlorine. So in this case, you have to ensure that you actually need to partition or do the electronic configuration for sodium. So with 11, you're going to say 2, 8, 1. So now this simply means that when you add together, 2 plus 8 is 10 plus 1, you get back 11. And then also for chlorine, you're going to, so is 8 to 8 as well as 7. So now remember that this chlorine is partitioned 2, 8, 7. So 2 plus 8 is 10, 10 plus 7 is 17. So you need to get back that number. Okay. And then now from there, you need to represent this before. Okay, I'm just going to actually show you before and after they have combined. So before they combine, so all you need to do now is to ensure that you draw this is what we call the shells. Okay. Okay, so depending on the number of these configurations, we have 3 configurations for sodium. Okay, so at the middle you can just put the symbol of the element, and then we are going to use the star. So you have these 2 in the first shell. So these are shells. Okay, these are shells. And then in the second, you're going to have 8. So we have 8, 8. 8, and then 2, 2, 2, 2. And then in the last shell, this bigger one, we have just 1. And this is the one there. So you kind of do the same with the chlorine. So you're going to have something like that. Okay. So we have the chlorine at the center, and then we're going to have 2. So I'm going to use the dots just to differentiate from the star. So make sure that you understand that. Okay. So in the second shell, I'm going to put 2, 8, and they are going to be in pairs of 2, 2. They are going to be in pairs of 2, 2. Okay, and then the last one is 7. So they are going to be in the pairs of 2, 2. And then the last one alone. So when you count these, we have 1, 2, 3, 4, 5, 6, 7. So now what's going to happen is that this sodium is going to actually lose 1 electron. Okay, so this sodium is going to actually lose this 1 electron. So 1 electron. So 1 electron must be lost, okay? And so 1 electron must be lost to the chlorine. So now this is before, okay, before they could actually just combine or form the bond. So now we have to show that. Now the most important thing is that this 1 electron is going to go to the chlorine, okay, and be added to the 7 there. So the 7 is going to become 7 plus 1 is going to be 8. Now it is given that according to the octet rule is that the chlorine, each of the last shells after the reaction, they must contain 8 electrons, meaning they are now stable. Okay, so after the reaction, the last shell must have 8 electrons. Okay, so now let's see how that will come out. Okay, so now the configuration is going now to be, after this one is lost, then it's going to be 2, 8. Okay, so this is the new. Once sodium loses 1 electron, it's going to remain 2, 8. And then for chlorine, it's gonna be 2, 8, 8. Okay, so we can now draw those stuff. So we are going to have, okay, so at the middle, so it's sodium, and then we are gonna actually use the star 8 in this one, 8. Okay, then in the middle, just, in the first shell, just 2. So now what you need to understand, you need to put kind of the brackets, okay? And this shows that the sodium has lost 1 electron there, so you're just going to put a positive, okay? Because it is just 1 electron. But if it was 2 electron, you would have just written like 2 plus or 3 plus, but since it's just 1, doesn't make sense to write 1 plus. Okay, so if it just 1 electron lost, you just write the sign, because we know that all metals, they carry positive sign. Okay, and then now the chlorine is gonna actually have 3 of them. Okay, so at the middle is chlorine, and we have 2, 8, 8. Remember that the last 8 has gained 1 electron from the sodium, and this is just going to be that. The second shell, it is 8. So pairs of 2, pairs of 2, pairs of 2. And then now the last one is pairs of 2, pairs of 2, pairs of 2, 2. And then now pairs of 2. So now the last one that was transferred to the chlorine must be indicated, that came from the sodium must be indicated as a star, so that we differentiate. Okay, so then this is going to be, and then you just put the bracket kind of. Okay, then how many electrons as the chlorine gained is just 1. But all nonmetals are going to carry a negative charge. So you're just going to write 1, -1 there. I mean, just negative. Okay. So remember that once you do this, then this element is stable now. So it's gonna just, what you're simply talking about is sodium, okay, reacting with chlorine, okay, to form simple sodium chloride. Okay, so it is this sodium chloride. Okay, so this is what you must be able to understand. Okay, so this is how you can represent sodium chloride in terms of bonding. So if you want to see more of these videos, please make sure that you subscribe, like, and also share our videos so that you don't miss any update from us. Okay, so now the next part is we're going to look at the covalent bonding, which is just the sharing of electrons between nonmetals only. So remember that this is a metal, okay, and a nonmetal. Okay, so let us now get to the covalent bonding, or rather, so what is formed? So the bonding in this substance, so this is what is now formed as ionic compounds, or ionic compound. Okay, ionic compound. So in this one, we are going to look at covalent, covalent. So covalent bonding. Okay, so when you talk about covalent bonding, we are simply saying that in this bonding there is only the sharing, okay, sharing of electrons. So the sharing of electrons between non-metals only, okay, non-metals only. Okay, so example you can give is on molecules such as let's say hydrogen, maybe also nitrogen and oxygen. Okay, so I'm going to give you examples on this one. So for nitrogen, hydrogen is that we have 2 hydrogens. So this is what we call diatomic molecule. So we have the hydrogen and another hydrogen. Now we know that the mass, the proton number for hydrogen is just 1. So just as got 1. So I'm just gonna say at the middle, symbol of the element, and then we just have the starlight. And then another hydrogen atom there, so hydrogen, and then we have a dot line. So now there is no transferred, whatever you may think is just a shared. So all you have to do is just put these guys together. Okay, you've got to put them together, and what you have now is a star at the middle and a dot there, and then this is hydrogen, this is hydrogen. Okay, so this is basically the simple way in which you can actually understand what we mean by covalent bonding. It's just the sharing of electrons between nonmetals. Okay, and now going to nitrogen. Okay, nitrogen. So nitrogen is 2, so I'm gonna have nitrogen and also another nitrogen. And this, what will happen now is we must be able to understand, because hydrogen was the simplest element from the periodic table. Now we are looking at the nitrogen. So for nitrogen, it has a configuration of I think 14, as well as 7 as a proton number. So what this implies that when you configure the 7 as we did in the ionic bonding, so it's just 2, 5. Okay, just 2, 5. And then this is the same with that one. So we're gonna actually have something like something like this. So for this one, the most important thing is just to show this last one, okay, because that is the most important thing. Okay, so we have the nitrogen there, and then we're going to write I think 4 there, then the last one there. Okay, then another one, just to repeat the same thing. So we have the nitrogen there, and then you're going to have these like the dot there, and then the other 2 pairs. Okay, so what's going to happen is we are going to actually share these electrons. So let us okay, so what's going to happen is that we are going to share electrons. So you're going to actually put 3 pairs. So you have this dot, then another one, dot, and then another one, and a dot. So what happens is that for the star, we have moved 3, 1, 2, 3. So there we just remain with 2 of them. Okay. And then this side on the dot, we have moved 3 of them, 1, 2, 3. So I'm gonna actually just remain with outside 2 of them. So now this is actually going to be when you count now in this nitrogen, which is more stable than the hydrogen. So we need to have that if I count the number of electrons in this other side of nitrogen, is that I need to come up with 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then on this other one, other one should also be the same. So the 1, 2, 3, 4, 5, 6, 7, 8. So this makes it stable. And now we have actually shared 3. So it's 3 shared 3 shared 3 shared pairs. Okay, pairs of electrons. Okay, and in this case we can just even indicate the nitrogen bond as 1, 2, 3. Okay, So it has got what is called this is a triple bond. Okay, triple bond. So make sure that you understand there. Then when you go back to the nitrogen, so we only have one. Okay, so for the nitrogen, just for the hydrogen, is just one pair. Okay, one pair of that. So one shared pair of electrons. So in this case is a single bond. Single bond as opposed to this one. Okay. So normally that is what you need to understand. So let us now see what's going to actually happen in the oxygen. Okay. So we have the oxygen. So I'm gonna actually. So we understand that oxygen has got 16 on top. When you look at on the periodic table, and then if we actually configure this one, going to be 2, 6. Okay, so that 2 plus 6 you get 8. Now we have 2 oxygen there. So what's going to happen is we have the first one is we show the O, which is oxygen, so 6. So in pairs of 2. So in pairs of 2. Then we have another oxygen, which is just O. I'm gonna use the dots, so 6. So pairs of 2, pairs of 2. Okay. So I need to understand that. So like for example this one. Okay. So I need to understand now how the pairing is gonna actually occur. So how the pairing is actually gonna occur. Okay. So if we move 2 of them at the middle, okay. So let's try to move 2 of them at the middle. So the star shared with the dot, and then another star shared with the dot. Okay. So in short, we have 4 shared electrons, and the remaining part is just going to be 1, 2, 3, 4, because you have taken these 2. So just do this and that, this and that. So when you count the total number of electrons, just these ones and also the paired ones, so they should be 8. 1, 2, 3, 4, 5, 6, 7, 8. So even this side, we have taken 1, 2, the dots, so the 2 dots have gone out, so it means 1, 2, 3, 4. So just those. Okay. So you can even distinguish the number of bonds formed in this oxygen. So we have, this is one pair, then the second pair. So now we have 2. So we have 2 shared, 2 shared, 2 shared pairs of electrons. Okay, and this can be shown as simply as oxygen 1, 2. Okay, so this is just going to be called a double bond. Okay, so a double bond. Okay, so guys, that is how we can share electrons. Okay, so I'm gonna actually give you an homework or task, a challenge to do. So on the fourth one, just do the one for water. Okay, now you have to be careful because we have two hydrogen, so and one oxygen. So just to give you a clue what is happening, you're going to have a single oxygen at the center, then bounded by two hydrogen. Okay, so for your information, we know that hydrogen is only the one. Okay, hydrogen is only the one, and this simply means that we're gonna actually, this is hydrogen and this is hydrogen. So this is gonna be, we take the that one from the hydrogen, and then we also take the other one from the oxygen. So we use the dots from the oxygen, and then one from the hydrogen again. So that is a star there, and another one from the same oxygen. And oxygen, remember, with this example, it has got 6. Okay, so we have actually used the dots for oxygen. I've used 2, so 2 out of 6 remaining 4. So I'm gonna actually get those 4 and bound them there. So when you count this now, it becomes even more stable than they may be individually. So 1, 2, 3, 4, 5, 6, 7, 8. So the idea is that whatever is being shared must actually, together with these individual ones, must come to a total of 8. Okay, a total of 8. So thank you so much, guys, and maybe you can do the bonding in a. Okay, so let me give you an assignment, a homework. Okay, so I want you to do the covalent bonding that occurs in this. Okay, and this is what we call methane. Okay, so work out this one. So this one might even carry 3 marks. Okay, might even carry 3 marks. So make sure we understand that. Okay, so thank you so much, guys, once more again watching. For those that have not subscribed to my channel, please do so in order to be able to receive all the updates and all the information from my channel. So this is Radical Academy, and this is Professor Mike, and thank you so much for watching. See you in the next video.